Figure given below shows a metallic square frame of edge A in a vertical plane. A uniform magnetic field B exists in the space in a direction perpendicular to the plane of the figure. Two boys pull the opposite corners of the square to deform it into a rhombus. They start pulling the corners at t equal to 0 and displace the corner at a uniform speed u. Find the induced EMF in the frame at the instant when the angle at these corners reduced to 60 degree. Find the induced current in the frame at this instant if the total resistance of the frame is R. And find the total charge which flows through a side of the frame by the time the square is deformed into a straight line. So these are the set of questions which is asked to us associated with this particular problem. So the first thing which must be kept in mind is that the side is moved with a speed u in the downward direction. So displacing the corner at a uniform speed u is mentioned in this particular problem. So let us draw a diagram to understand this problem first of all. So this is the square which we are talking about, which in turn is going to be converted into a rhombus such that the side is going to form an angle of 60 degree. So if the side is forming an angle of 60 degree, so if I draw a line like this, so over here I can say that this angle is equal to 30 degree. And if this is the side length which we are having, so we can calculate the perpendicular length which is going to be equal to a sine 30, and down here also it is going to be a sine 30. So this is the first set of change which we have. So if I write the value equivalent to the perpendicular length of velocity, so the length is going to be equal to 2a sine 30. Sine 30 is going to be half, so the value is equal to a. Now the EMF induced can be calculated in this way. Therefore EMF induced is going to be equal to BLV. So this is the formulation which we use, that is BLV. Now since both sides are moved with a speed u, both the sides are moved with a speed u, so due to both the side being moved with a speed u, the value of velocity which we are going to use over here is the relative velocity, that is 2u. So we can say that the EMF induced is going to become B into A into 2u. So the value that we have is equal to 2BAU. So the next thing which is being asked over here is the value of current. So if we calculate the value of current induced in the frame, so current induced in the frame is equal to EMF upon R, that is we divide by the value of resistance. So over here we obtain it as 2BAU upon resistance, which is equal to R. So in the next part, the question is asking us what is the value of charge that is going to flow as this deformation is going to take place and convert it into a straight wire. So as it will become into a straight wire, so the value of charge flown can be calculated as current into time, and on performing the calculation we will obtain a value equal to A square B by R. So the value of charge flown can be calculated as A square B upon R for this particular problem.